Hello mates. I'm sorry. In the previous video, I was now rushing. The things I use a camcorder that uses those small discs. So it records like 30 minutes. The 30 minutes almost over. So I was just now rushing and all of that because I have to empty the contents of the disc onto my laptop, bring it back to the camcorder, format it and record some more. So the process becomes a bit too much, but now let's not be lazy. Oh well, unless someone donates a better camcorder, but for now let's just make do with what we have. I hope we are seeing. Sorry for the bad quality. I'll improve with time. Like I lost one of my lamps, so yeah, I'm just using only one desk lamp. I would be grateful if anyone can just donate another lamp. I do not know where the other one is, so the quality is pretty bad. Okay, enough of complaining. Let's get back to our example. Our example that we're doing in the previous video was this one here. We had forces Q, P, 14, 8, and 12. And 8 was at an angle 60 degrees to 12. So, as a recap, I said the first step that you need to do when you're dealing with forces is to choose two perpendicular directions. So I chose the vertical and the horizontal as my two perpendicular directions. And then I started putting these forces in the right directions, respecting the new coordinate system or the new directions that I will be using. So I saw that Q is vertically upwards according to this system, so Q was just vertically upward. And then I saw P was was horizontally to the right, so P just maintained its horizontal direction. And I saw 14 was also vertically downward, so 14 maintained its vertical direction like this, vertical downward. And then 12 was horizontal to the left, so 12 was horizontal to the left. This is now a point that I skipped. The point that I skipped is force Q. Force Q is vertically upwards. When you're doing tug of war, imagine there's only point Q. There's only force Q. So let me remove this because it's better discussing that point first. Because if we can discuss that point first, it is the foundations of resolving forces. If you guys understand that force, understand that point, then you will understand resolving way easier. So let me just okay, scrap this off. Yeah, all right. So the point is this: if a force is 100% along a direction, it will not have an effect on the other direction. What I mean is, can you see Q is vertically upwards? It's vertically upwards, so it has no effect in the horizontal direction. It only has an effect in the vertical direction. This is true because imagine you only had force Q vertically upwards like this. This object here would not move anywhere in the horizontal direction. It would only move up. It will only move up. Or if Q was facing down, it would move down. So Q only has an effect in the vertical direction. You see, it only has an effect in the vertical direction. Point P is 100% lying on top of the horizontal direction. It's a horizontal force, so it has no effect in the vertical direction. If P was the only force, this object would have moved to the right and not anywhere up or down, because this force is horizontal. It has no effect in the vertical direction. So that's why I put these forces like this. Q is vertically upwards. That's why Q is just facing up. No other effect of Q in any other direction. P is facing horizontally to the right, so P is just horizontal like this. No other effect in any other direction. Same applies for 14, vertically downward. Same applies for 12, because they are both in the directions that I chose here in this system. But 8 is at an angle. Since 8 is at an angle, it will have both a vertical and a horizontal component, like I tried emphasizing in the previous video. If it's at an angle to any one of these directions, it will have an effect in both directions. So it has an effect in the horizontal and in the vertical. what is left? Okay, the next step now is to see, okay, which vertical and which horizontal. Is it vertically upwards or vertically downwards? Is it horizontally to the left or is horizontal to the right? Now you just have to look at the force. You just have to look at the force. Where is it facing? It's facing a bit down and a bit to the left. So it will have an effect in the horizontal left and in the vertical down. I hope that makes sense. If it's facing a direction like this, let's say this, you see, in my case, these are my directions. This is vertical, this is horizontal. A force like this, it will have effects in this vertically downward direction and the horizontally left direction because of its what? Of its direction. If it was a force like this, it will have an effect in the horizontal right direction and the vertically upwards direction because of its what? Of its direction. A force like this, same applies. A force like this will have an effect in the horizontal right and the vertically downwards. A force like this will have an effect in the vertically up and the horizontal left because of its direction. Its direction is trapped in the second quadrant, so it will have an effect in these two. This one is trapped, the direction is in the first quadrant, so it has an effect in these two directions. This one is in the fourth quadrant, so the effect is in these two directions. And this one here, it's in the third quadrant, so it has what? Effect in these two directions. I hope you understand that. I hope you understand what I mean. So let's look at our force 8. Our force 8 will definitely have an effect in this direction and it will have another effect in that direction. When I say effect now, that is where resolving comes in. It's called resolving the force. The effect that I'm talking about are these two. Okay, resolving is coming up with two forces that represent that single force. Since we have said it has an effect in this direction and this direction, we can assume that it wasn't there. When you assume that it wasn't there, we are going to say it has been broken down into two components, the vertically downwards component and the horizontally left component. These two components here, they represent 8. 8's effect. 8's effect is to bring this object to a point called xy, right? That is the effect of what? Of 8. It is to bring that object to a point called xy. So if that is the effect, these two would send the object to point xy just in the same manner as if we are having one force, the 8 newtons. So these ones are called the components of the force. So when you're solving for forces, if a force is at an angle to any one of these directions, you need to get these two. You need to, like in this case, you see this 8 is at an angle to the horizontal direction. So you definitely need to resolve it in this case. I'm resolving it in the horizontally, in the vertical and the horizontal directions because that is the coordinate system I chose here. So whenever a force is at an angle to any of these directions that you have chosen here, you need to resolve it with respect to the what? You need to break it down to forces that are perpendicular to each other, respecting the coordinate system that you have chosen. So this is what I'm basically doing. So let's see how the resolving would happen. Here we have 8, and this one is what? 60 degrees. Okay. So now we are going to use our sin, cos, tan rules. This is what we are going to use. I'll tell you a shortcut later, but the mathematics behind this is this. This force here is a length. We can represent its strength. It's 8 newtons by a length. We can say, okay, this force here, it has a length of 8. We can call that length 8. So we're just going to have what? 8 as what? As the hypotenuse. Because can you see, let me create a triangle like this. I'm going to create a triangle like this. It's a right angle triangle at that corner there. It's going to be a right angle triangle. So this is now the hypotenuse, the force I've made the force the what? The hypotenuse. So now it's a matter of calculating this and calculating that, and you see where that those will come in. We already have an angle, so this is opposite, isn't it? It's opposite the angle. So we are going to use sine to calculate this y, and we are going to use cos to calculate this x because it's what? It's adjacent to the what? To the angle. So my y is equal to the hypotenuse 8 sine the angle. Sine is what? Sine 60 degrees. That is equal to my y. And my x is equal to 8 cos 60 degrees. By now you know how to do how to use sin, cos, tan. So this is what? This is my y, this is my x. But can you see this y is parallel to this vertically downwards direction. This y is parallel to the vertically downwards direction. So I can transpose this y here and I can put it here because they have the same what? Same length. So I can put the y there. What I've basically done is I've resolved this 8 Newton into two forces, the y force and the x force, using the what? Using sin, cos, tan and the angle. So my vertically downwards component is 8 sine 60, and my horizontally left directed force, the x, is 8 cos 60. So now this 8 can be represented by two forces that are like this, which is 8 sine 60, and here which is what? Which is 8 cos 60 degrees. So now I no longer have that 8 that is inclined. I now have two forces that are representing this 8 Newton, but they are now respecting my what? My two directions. They're now respecting my two directions. So the 8 cos 60 and the 8 sin 60 together, when they are together, they will have the same effect as the 8 Newton force that was initially like this. So where does this help? It helps us in our example because now we are getting rid of this and just having a force in this direction and a force in that direction. So let's rewrite our example now. Let's rewrite our example. So rewriting our example, we will have our directions like that. So here we have our Q, here we have a force P, here let's see, here we have a force 14, and here we had our force 12. So instead of writing our 8 that was like this, we are going to put the what? The components. With the component that was vertically downwards like this now, which is called what? It's let me take where oh no, I wrote it here. Yeah. It is what? 8 sine 60. So here in the vertically downwards direction, we have a 14 that is pulling downwards. But we also have the what? The 8 sine 60. Can you see? So we are going to add 14 plus what? Plus 8 sine 60 degrees. Because these are the forces that are pulling vertically downwards. They are helping each other. There's the 8 sine 60, the component of the 8 Newton force, is pulling vertically downwards. But we also had a 14. So the total vertically downward force is 14 plus 8 sine 60. Same applies to the 12. We had 12 initially, but we now have an 8 cos 60, the component of the 8 Newton that is vertically to the left. So we are going to add the 2. We are going to add the 2 to get the total pull, the total strength that is going to the left hand side. That's what we basically mean. The total strength that is going to the left hand side is what? 12 that was originally there, plus 8 cos 60, the component of the 8 Newton that is to the left hand side. So these are our forces. Now it's just a matter of applying equilibrium. We're told with the question that the forces are in equilibrium. So what is pulling to the left, what is pulling to the right actually is equal to what is pulling to the left. What is pulling upwards is equal to what is pulling downwards. Now equilibrium just makes it fun. So P to the right is equal to 12 plus 8 cos 60, which should be something like 12 plus 4 root 3. I'm not quite sure, but I think it's like 12 plus 4 root 3 or something like that. Oh no, cos 60 is actually a half. I do not know why I was lying there. So this is actually a half. So this is 12 plus 4, which is equal to 16 newtons. And then the other part is Q is equal to, it's pulling vertically upwards, right? So since there's equilibrium happens when they say there's equilibrium. That's a point that I didn't raise. But when they say there's equilibrium, it means the forces pulling up are equal to the forces pulling down. I didn't emphasize that point. I had said it before when we discussed the equilibrium in the previous videos. But that's what we're basically applying. There's equilibrium, so the forces pulling to the right are equal to the forces pulling to the left. That's what we did here. The forces pulling up are equal to the forces pulling down because this object is in equilibrium. So my Q pulling up should be equal to what is pulling down. What is pulling down is 14 plus 8 sine 60, the total force pulling downwards. So that one will be equal to 8 sine 60 is root 3 over 2. Root 3 over 2 times 8 is 4 root 3 plus 14, which is 14 plus 4 root 3 newtons. So we have solved for our P and our Q. This is basically what happens when a force, so I need to emphasize that part. When a force is at an angle, you have to resolve it into what? Into components. You have to resolve it into two components that are respecting the coordinate system. It's at an angle to the coordinate system, so resolve it into components that respect the coordinate system that you have chosen. As you see here, like what I've done. I said, so just for the last part of this video, let me show you a simple shortcut that I normally use, because in the exam maybe we press for time. So for you to start drawing right angle triangles, it might take time. Can you see this force here? The 8 newtons is trapping this angle with the what? With the horizontally left direction. It's trapping this angle between, okay, this angle is trapped between the 8 newton force and the what? And the horizontally left. So when it's between like this, the component here, this component here is the one that we have cosine. So this one will automatically become 8 cos 60. The other component that is not trapping the angle is the one that will become 8 sine 60. It will be automatic like that. You can prove that using what? Using the sin cos rules that we did on the previous video. But this is just a faster way of doing it, because sometimes you are given forces. Yes, sometimes you are given a 2 newton force that is at 30 degrees. Here you are given a 4 newton force that is at 20 degrees, and here you are given a 6 newton force that is at 45 degrees. All you have to do is to think you have to choose what? A coordinate system. I've chosen this as my coordinate system, the vertical and the horizontal. Now look at the 2 newton force. This 2 newton force, it's trapping this 30 newton what? It's trapping this 30 degree angle between what? Between the horizontal, this side. So this side is one that we have a component of cos when it comes to what? To 2 newton. So this one will be 2 cos 30. There will be a 2 cos 30 component here. So the other what direction? The other direction here is the one that we have a sine. So here I'll have a 2 sine 30. I've broken down the what? The 2 newton force. Same applies for the 6 newton. The 6 newton is trapping this 45 degrees between the what? Between itself and the what? And this horizontal direction. So this direction is the one that we have cosine when it comes to the 6 newton. So in this direction, I also have another force, which is 6 cos 45 degrees. Is the what? Is this side. But the other direction is here, because obviously, see, with the direction of the 6 newton, is going to be horizontally right and vertically downwards. So vertically downwards, the other direction that is not trapping the angle is the one that we have sine. So this one will be 6 sine 45. And then for the what? So you see, I'm no longer writing the 6 newton. I now have two components, the 6 cos 45 and the 6 sine 45, representing the 6 newton. Let's do that to the 4 newton. For the 4 newton, due to its direction, it will have a component here and a component here. The component that is in this direction, can you see, is the one that is trapping what? The angle. It's the one that is trapping the angle. Since it's the one that is trapping the angle, it will have the what? The cosine. So here it will be 4 cos 20. And the other direction here, the other component that is not trapping the angle is the one that will be sine. So here it will be 4 sine 20. And now, if you're told this equilibrium is just a matter of you applying what? It's just a matter of you applying the tug of 4. What is pulling upwards, the 2 sine 30 should be equal to the total of what is pulling downwards, 6 sine 45 plus 4 sine 20. What is pulling to the right should be equal to what is pulling to the left. So 2 cos 30 plus 6 cos 45 is equal to 4 cos 20. Then you just solve for whatever you want to solve. Let's say there was an F or an R or whatever. They should be in equilibrium. I don't think these forces are in equilibrium because I just thought about them in my heart from the top of my head, just to emphasize the point of breaking down forces into components. So in the next video, I'm just going to talk about forces that are not in equilibrium, just to see how to take that further step. All right, stay tuned for that video.